So these first, it's going to look like we have a ton of stuff, but these first examples are just to kind of get us in that mindset of, okay, domain and range, what does it mean to be increasing and decreasing on a function, and what do some negatives do to our function. We're going to also look at how to plug things into our graphing calculator and be able to look at a table and figure out kind of what our table tells us about our function, okay? So if I asked you what the graph of the square root of x looks like, what would you show me with your finger in the air? Something like what? What would it look like? X squared. Or sorry, the square root of x. What does it look like? Square root of x. Nope, that's x. That's the cube root of x. Yes. No, it's not a parabola. Square root of x. Yep, just one side. Okay. It looks like this. If I plotted a few points, I would have the square root of 1 is 1, square root of 4 is 4, right? And it would look like this.
Just goes that way.
Okay? Yep. Because can I take a square root of a negative number and have a point on an actual graph? No, I cannot, okay? So if I'm looking at this function, remember, domain are all of my x values. Okay, so if I look at this function from left to right, what is my smallest x value that I start at? 0, and I go all the way to infinity, right? So I go from 0, I include 0, right, all the way to infinity. And if I were to also write this in terms of an inequality, I would say my x's are greater than or equal to 0. Okay, it's important to look at it like that. We should be able to kind of go in between these two things when we start solving here for our domain. This is how we're going to get it, and we need to write it in terms of interval notation. Okay. Now my range, those are all of my y values. Okay, so my smallest y value all the way up to infinity, right? So range are your y values. Starting from 0 and going all the way up to infinity. Now, if I were to write this as an inequality, I'm not going to use x's this time. I'm going to use y's. So it would be like y is greater than or equal to 0. Okay? Now, looking at this function, as I look from left to right, okay, what is happening to my y values? Are they getting bigger or are they getting smaller? They are getting bigger, right? So that means it is increasing on that function, right, from 0 all the way over to infinity. Okay, so I would write it is increasing from 0 to infinity. Okay, is there any part of this function that is decreasing from left to right? No, it's all increasing, right? So there's none that are decreasing. Okay, the next graph we're going to look at is going to be the same parent function, however, we're doing some sort of transformation to it, okay? There's going to be a negative in front. So look at example 2 here. What about the graph of negative square root of x? How could we use that parent function to graph it? Because some of this stuff you'll be able to use your calculator, some of it you won't be able to, right? So what are we thinking? Yes, we are going to flip it over the x-axis, okay? So I would take all those points that I just had at 0, 0, which would stay 0, 0, because I can't flip that, right? It would be the same. 1, 1 would become 1, negative 1, and 4, 2 would become 4, negative 2, right? So this should be something that you should be able to think, what does this graph look like without a calculator? Okay. So now I look from left to right. As I look from left to right, what is my domain of my function? 0 to infinity. Now my range, I'm starting all the way down at negative infinity, going all the way up to what? 0. So it'd be from negative infinity to 0. And if I also wanted to write these as inequalities for my for my domain, I would write this as still x is greater than or equal to 0, right? What would I write for my range though? Y is how related to 0? Less than or equal to. Okay? Now we're looking at this function. as I go from left to right, what is happening to all of my y values? They're getting smaller, right? They're decreasing on that entire interval. So I would write from 0 to infinity, it is decreasing. Okay, it's asking us what are the x values that are creating more and more negative y values. Okay, so there is no increasing function part of this graph. Bless you. Okay, what about example 3? What does the graph of y equals the square root of negative x look like? This one was the negative in front of the square root of x. Now this one is with the x.
It shrinks.
Not shrinks.
Darn it. Oh, it stretches anyway.
Not stretch.
Does it flip the other way?
It flips the other way. That's exactly right. So our parent function normally, right, looks like this. Not quite like that, but kind of like that, right? If I plug in a negative value, right, negative 4, if I'm at negative 4 and I evaluate this, doesn't that give me 2? If I plug in that value. So it's flipping it over that y-axis. So I'm going to plot my points here. I've got 0, 0, negative 1, 1, negative 4, 2 of my sketch. If I plugged in a positive 4, it wouldn't exist, right? Because I can't take the square root of a negative, which is why the graph stops here. Yeah. Okay, go ahead and answer those 4 questions. What would my domain be? What would my range be? And then is there an increasing or decreasing interval, and what is that? All right, so we should have our domain, negative infinity to 0. What is my range? 0 to infinity. Okay, and then this one's kind of tricky for some of us here. If I look from left to right on my function, are my y values getting bigger or smaller? Smaller, okay? So it is decreasing on the interval from negative infinity to 0. Okay, it is not increasing, so none here. Okay? Do we kind of understand the idea here of domain, range, and when it's increasing or decreasing? Okay, on this next example, which is on the next page, okay, on this next example, I'm going to kind of skip it, but I just want to talk about it quick. Okay, it puts both previous examples together. It has a negative and then a square root of a negative x. Okay, so on your calculator real quick, let's graph this one on here. Okay, so you're in your y equals, and you're going to type in negative square root of a negative x. Okay, and you're going to hit graph. So you're going to go into your y equals on your graphing calculator, and then you're going to type in this function here of negative x. Negative square root of negative x.
It says negative 2.
What? So if I look at this function, it looks something like that. A quick little sketch, right? Terrible kind of sketch, but we could identify the domain, the range, the increasing, decreasing on this, right? Is this increasing or decreasing as I look from left to right? It is increasing, right? All of my y values are getting closer and closer to 0, okay? All right, so those were square root graphs. Let's talk quick about a cube root graph. What does a cube root graph looks like?
The Egyptian.
Yeah, the Egyptian, yes, okay? So if you plug this one in your calculator as well, okay? Plug in the cube root, so you're going to have to go to math, option 4, and I'm typing in x. Yep, graph this on your calculator. If you choose math, option 4, once you're in your y equals, it will create your cube root of x, and then you can graph it. Okay, so I'm going to go ahead and quick plot this on here. Okay, what is my domain going to be for this function? Negative infinity to positive infinity, right? Everything from left to right. There's arrows going both ways. What about my range?
Probably the
same thing, right? Because those arrows, it's continuing forever and ever to grow, right, in the positive and negative direction, okay? Now, with this function, this is like our parent function, right? There's no transformations happening. Is this function increasing or decreasing as I go from left to right? It is increasing, okay? Increasing on the domain from negative infinity to infinity. It is not decreasing at all.
Is it ever going to be increasing?
Increasing and decreasing at the same time? No. But could it sometimes be decreasing in the terms of these square roots or cube roots? Yes. What would I need to do to this function in order to make it a decreasing function? Put a negative in front of that, right? If you go ahead on your calculator and add a negative in front, oops. No, I don't think it is actually. But you should be able to see your graph create something that looks like that, right, in red. So that would be a decreasing function from negative infinity to infinity, okay? All right, so now we gotta notice a few things about if we have odd roots or even roots, okay? If we have an odd root, that means anything like the cube root, the fifth root, the seventh root, whatever, okay? Is the domain ever going to be restricted?
No.
No. Because why?
Because you have negative.
What do you mean?
Like if there's like if it was a square root and there's a negative, that's restricted. But since his cube is odd, you would have it 3 times or 5 times, which would always make it back to positive.
Yes.
You can graph that.
Yes. Like I can take a cube root of a negative number is what you were trying to say, yes? Yes. I cannot take a square root of a negative number, right? So that means I can plug in any number, right, into my function if it's an odd function, an odd root function, and I will get an output, okay? So your domain is always going to be negative infinity to infinity, and it is never restricted for an odd root function. Okay? The domain of an even root function, however, so like if I had the square root or the fourth root, right, or the sixth root, I cannot take the square root of a negative number. So therefore it is restricted, and it's restricted how? Yeah, so all of those numbers under the square root have to be bigger than or equal to 0, right? So there is a restriction, yes. It has to be greater than or equal to 0. Okay? All right. Big ideas, look at a few examples. We'll be done. Okay, big ideas. I'm going to rewrite the same exact thing here. Okay, when we have even roots, you must have, oh, that's way too large. Must have square root be, actually I don't like how I wrote that. I'm going to say must be positive or 0 under the radical. Okay, any square root, even root, whatever, okay? Odd roots for domain, there is no domain restriction. Always negative infinity to infinity. You could write all real numbers unless it says to write it in interval notation. Yes, and then write it negative infinity to infinity, okay? All right, so you're going to be given some functions here, and you're going to be asked what is the domain, maybe what is the range, what is the increasing, decreasing, that kind of stuff. So if I look at this function here, I got to look at what is the root, is it even or odd? If I look at example 6, is this function an even or an odd function? Odd root, even root, which one?
Even.
It is an even root, right? So I need to account for the domain. I need to account for the 4x plus 12 being greater than or equal to 0. Okay, so I'm going to set up an equation here, 4x. Why did it just get so small? writing there for a second. Okay, 4x plus 12 greater than or equal to 0. Okay, remember anytime you're solving inequalities and you divide by a negative, what do you have to do? Flip the sign, right? This case is not actually the thing that you have to do that for. But if I get 4x less or greater than or equal to negative 12 and I divide by 4, I get x is greater than or equal to negative 3. Okay, so in order for this function to be defined, x has to be greater than or equal to negative 3. You're going to have to write this in terms of interval notation. So if you're not a visual person, you can't think of what does that mean in terms of a graph, well, just draw yourself a quick little number line. At negative 3, think, okay, any x bigger than that would be to the right. Okay, so if I'm writing that in interval notation, it would be from negative 3 to infinity. That is your domain for this function.
That makes sense.
Okay, yes, question. All right, number 7, what is the domain of this function? Is it even or odd? It's an odd root, right? Wait, no, it's an even root. Okay, so we do have a domain restriction, right? So I have to set 25 minus x squared greater than or equal to 0. If I solve it, I get 25 is greater than or equal to x squared. And if I take the square root of this, I get not just one answer, but positive and negative 5, right? But what does that mean in terms of my function, right? The negative 5 and 5, right, are included because I have greater than or equal to, right? But we got to test a point here to see what makes my inequality true, right? If I test 0, if I test the point 0 and I plug it back in here, 25 minus 0 squared gives me 25, right? So that is true that is greater than or equal to 0, right? Interval in between. What about something bigger than 5? Let's say 6. If I plug in 6, 25 minus 6 squared, is that greater than or equal to 0? Well, 6 squared is 36, right? So 25 minus 36, that's going to give me a negative number, right? So I can't have x's bigger than 5, okay? This is not true. Which means if I plug in a number on the left side, negative 6, I'd have 25 minus still 36, right? Because I'm plugging in negative 6 squared in parentheses. Is that greater than or equal to 0? No, right? I will get a negative. Okay, this graph is a little funky, so go ahead really quick on your graphing calculator. So I'm going to guess no one has any clue really what this looks like. If you graph the function with a square root of 25 minus x squared, you get this weird little semi-circle ellipse thing. Okay, your graph should look something like that. From negative 5 to 5.
How do we do it?
If I write this as an interval, right, my domain that makes this function true would be everything in between negative 5 and 5. Okay? All right, number 8 is a quick one because what kind of root function do we have, even or odd? It's an odd. So if we have the domain of an odd root function, my domain will always be negative infinity to infinity. Oops. No, as long as it's asking you the domain of an odd root function, you can just say negative infinity to infinity right away. Okay? You can say all real numbers unless it says to write it in interval notation. Okay? You just got to remember when to use what. Okay? All right. Example 9. This will be like the last few questions on your homework where you're just identifying a few things by hand and by using your graphing calculator. It says to find the domain. So we're going to find the domain by hand. And then we're going to use our graphing calculator to find the range. And on the graphing calculator, we'll be able to see where it's increasing or decreasing. And this last part we can do by hand, and we can also do on the calculator. Okay? we're going to solve the function f of x equals 0, which means my y value is 0, so what am I actually finding? The x-intercept, right? So we can look at the table to find that as well, okay? So let's first do this by hand. We're going to find the domain of letter A. So if I went, I like this function, it's an odd or an even root. Which one? It's even, right? So I have to set up an equation or an inequality, 2 minus x greater than or equal to 0.
What about the negative?
I don't care about the negative in front. I care about what makes this stuff underneath the square root greater than or equal to 0, okay? Yes, I know that negative is going to do something to my function, but right now I just need to solve this one, okay? So I'm going to add that x over. I get 2 greater than or equal to x, or I like to have my variable on the left side, so I get x less than or equal to 2, okay? Or in terms of domain, if you think about a number line at 2, it's everything to the left, right? So our domain would be from negative infinity to 2. Okay, now on your graphing calculator, real quick with me, we need to plug in negative square root of 2 minus x. We need to graph that. I'm going to draw a sketch up here of what you should be seeing on your screen. On your graphing calculator, you should see something like that in blue that I have there. So now we can look at what is my range of this function. Negative infinity for my y's, yes. And I go all the way up until 0. Yep. So negative infinity to 0. And I do include 0 because I do have a point at 0. Well, not at 0, but 2 comma 0, right? And then is our function as we go from left to right, is it increasing or decreasing? It is increasing for that entire interval, right? So from negative infinity to 2, it is increasing. It is never decreasing. Okay? Now to find our x-intercepts, we can do this by hand, and we can also do this by using our calculator. Okay, let's do it by hand real quick first. If I want to find the x-intercept, I'm going to set the equation equal to 0, right? Because that's my y value. So I've got 0 equals negative square root of 2 minus x. You can, yes, and you'll be able to look on your graph too. But I'm showing you how to find it if it's not a nice number, okay? So if I were solving this, I would divide by -1 on both sides. I'd get 0 equals the square root of 2 minus x. How do I get rid of a square root? Square both sides, right? Which means I have 0 equals 2 minus x. Which means, yes, in this case, x is 2. And yes, we can see pretty easily on our graph that it is at 2. Now, on your quiz, some of you guys messed up writing your x-intercepts as equations. We need to write them as points, right? So I need to write this as 2 comma 0, not as a equation. Okay? Again, we plugged in 0 for y, right? Because my x-intercept is always going to have a y value of 0, and then I just solved this equation for x. Now, on your calculator, we, on some of yours, messed up the kind of format of our table. Because if you hit second graph, some of you guys might have stuff in there, some of you guys might not, okay? If you do not have stuff in your table, you need to go second window, and then you'll have a few things in there. It says table start. Let's just put that at like -5. Okay, that just means where is the table starting at on your for your graph on your thing, okay? And then the independent, we changed it to ask so that we could type in whatever value we wanted. Let's change that back to auto. Because now if I go second graph, we should have a bunch of x's and y's listed starting at -5, going all the way down to whatever yours is at. And you might see a bunch of errors. Oops. Okay. Errors are good, or they're okay in terms of this, because the cube root, or sorry, not a cube root, but a square root function, right, is going to stop at some point. So anything to the right of 2 should have error after it, because we can't have a value past 2 in this graph, right? So if you look at your table and you see where your y value is 0, that is your x-intercept, right? So look for your 0 value in y. You will see that it's also listed here as 2, 0. So that is also your x-intercept that we found by using the calculator, okay? By using the calculator, okay? Anyone need help finding that on the calculator? Do we all see how we got the table? Yes? Okay. Then we're gonna just do one more example here. That's on the next page, isn't it? Okay. Last one. We're gonna skip these last 2, okay? Just do letter B here. I've got a cube root function. Cube root function. Does domain have a restriction with a cube root function? No. So my domain is just negative infinity to infinity. Okay, what about my range? Same thing. Okay. What do we think? Is this increasing or decreasing?
It would be
Increasing, right? There's no negative in front of here, right? So it didn't flip it or anything. So it is increasing on that entire interval. Okay, if you weren't sure though, this would be something that you can plug in. Let's go ahead and do that really quick. So in your y equals, go ahead and plug in the cube root. So remember, you have to hit math. And then you're choosing the 4th option. And 7x minus 21. Oh, yeah, plus 21, sorry. Thank you. Okay. Okay, so it is not decreasing at all, right? Identify what your x-intercept is using your table. Okay, so go second graph. Looking at your table, what is your x-intercept? How am I going to know what my x-intercept is by looking at the table? When y equals 0, right? When y equals 0, it's at -3. So you have your x-intercept as -3, 0. Do you have a question?
No,
Okay. So we can find it via the graphing calculator. Okay, we can also find it by doing it by hand. So let's do it by hand really quick. If I'm doing this by hand, I would set 0 equal to the cube root of 7x plus 21. Okay? Now to undo a cube root, we would have to cube both sides, right? So I get 0 still is equal to 7x plus 21. And if I solve this equation, subtract the 21 over, we end up with x equaling -3, which is exactly what I got on my graphing calculator. Okay, so sometimes you'll be able to use your graphing calculator, sometimes you won't, so you'll need to be able to know how to solve both ways. Okay?